Good evening, Dhanlakshmi.
Good evening.
Dhanlakshmi, for the first year, can I go with oscillation waves? Because from
Yes, sir.
chapters, you will get around 3 questions for your exam, for your NEET exam,
Yes, sir.
oscillation waves. Or you have any
Sir,
particular topic?
important questions based formulas, sir.
Yeah, sure.
Yes.
In the oscillation chapter, you must know what is the general equation of the simple harmonic motion. Y is equal to A sine omega t. A sine omega t. Now, what is this A represents? Amplitude. Now, for example, if y equals to 3 sine omega t, what is the amplitude? Amplitude is 3. Suppose if I give the equation like this, 3 sine omega t plus 4 cos omega t. How the 3 and 4 are related? One is sine, the another one is cos, means this 3 and 4 are perpendicular to each other. 3 and 4 are perpendicular to each other. If 3 and 4 are perpendicular to each other, the resultant amplitude will be 5. Pythagoras theorem. So please be very careful when you have your two functions like this. You have to be very careful in telling the amplitude. If one is sine, the another one is cosine, then the resultant amplitude should be equal to root of 3 square plus 4 square. That is root of 9 plus 16. That is root 25. Root 25 is 5. The second formula. They will ask you about the concept of the velocity. Velocity of the simple harmonic motion is given by y is equal to omega into root of a squared minus y squared. What is the velocity of the particle executing simple harmonic motion? V is equal to omega into root of a squared minus y squared. What about the acceleration? Acceleration is nothing but minus omega squared into y. Then you must know what is the expression for the kinetic energy of the particle executing simple harmonic motion. It is half times of m omega squared into a squared minus y squared. What about the potential energy? Potential energy is given by half times of m omega squared into y squared. What is total energy of the particle executing simple harmonic motion? It is of m omega squared into a squared. So this are the total energy in the case of oscillation. Addition to this, you know the formula for the time period of the simple pendulum. Time period of the simple pendulum is given by 2 pi into root of L by G. So clearly this tells time period is directly proportional to the root length. Now, if I say the length is increased by 2%, then what is the percentage increase in that time period? What is the percentage increase in the time period? So this is the formula usually they are going to ask. You have to make use of the absolute error here. You know that the time period is directly proportional to the root of the length. So T is directly proportional to root length means L power 1 by 2. So what is the change in the time period? Change in the time period is half times of the change in the length. So please be very careful. This change in the time period is equal to half times of the change in the length. And this is applicable only for small percentage. Be careful that also. If this length is almost up to like 8%, 6%, almost less than 10%, you can make use of this formula. So if length is increased by 2%, what is the increase in the time period? Almost it will be half times of delta L by L. What is the percentage change in the time length? 2%. So this clearly tells delta T by T is equal to half times of 2%. Half times of 2%. So what is half times of 2%? It will be of 1%. So if the length is increased by 2%, the change in the time period is going to increase by 1%. Remember this. There is one more concept related to this only, Appa. Yeah, Tanush also joined. Good. Yeah. Now there is one more problem related to this. If the length of the pendulum wire is increased by 100%, if it is increased by 100%, then what will happen to delta T by T?
Sir, increases by 50%.
Increases by 50%. Yeah. Then Lakshmi, that is what I said here. Whatever the formula you are using here, by using this formula only you said right.
Yes, sir.
Yeah. But I have written one condition. Look at that.
It's a small percent.
Yeah, very good. Very good. But here, what is the percentage I have given?
So it's a large percent, sir.
So in this case, you have to go for the different method. Like L1, if it is L, what will be the second length? When it is increased by 100% means it increases by 2L, no? It becomes double, no?
Yes, sir.
So L1 is L, L2 is 2L. So this clearly tells change in the time period is nothing but directly proportional to root L. So root of L2 by L1 minus 1 into 100%. Since the change in the time period is directly proportional to root length, original final length by original length minus 1 into 100%, but here it is root. Now, can you tell me what is L2? L2 is 2L. L1 is L. L ಮತ್ತೆ L ಏನಾಗತ್ತೆ?
Cancel out.
So what is the left out term? Root 2. What is root 2?
1.4.
Yeah, 1.41 minus 1 is there. So 1.4 root. Root of 2 is 1.414 minus 1 into 100%. What is 1.414 minus 1? 0.414 into 100 is there. So it is 41.4%. So initially, if you go with this method, you are going to say it is 50%, but that is not option. For larger percentage, you have to go for this method itself. So this is one problem usually they are going to ask in the simple pendulum. After this, acceleration is minus omega squared into displacement. You know that acceleration is given by force by mass. For the spring, the force constant is kx by m. I'll take only the magnitude omega squared x. So x and x will get cancelled out. Omega value will be root of what? K by m. Omega can be taken as 2 pi by t, which is equal to root of k by m. So time period value will be equal to 2 pi into root of m by k. So this is the formula for the time period of the what? Spring. But please remember, if the two springs are attached like this, having mass m, spring constant k1, this spring constant is k2. Then the effective spring constant is here, k1 into k2 by k1 plus k2. This is for series combination. K effective can also be taken simply addition k1 plus k2. This is for which combination? Parallel combination. So here also you can connect the springs like this. One spring. This is the spring and one mass is attached here. This is K1. This is K2. Now you have a look. Between the two springs, if the mass is not attached, then this is called series. Between the two springs, if the mass is attached, then it is called parallel. So between the two springs, if the mass is attached, then it is said to be a parallel combination. Parallel combination. If only one mass is attached, so you have to be very careful while using these particular spring concepts formulas. So these are the problems on the oscillations. So more concepts there. Simple pendulum, spring, then equations of the simple harmonic motion. Equation of the simple harmonic motion, it will come under velocity, acceleration, and energy all put together. So these are the three concepts what you are going to analyze in oscillation chapter. Coming to waves, first concept you must know about the progressive wave. What's the general equation of the progressive wave? Y equals to A sine omega t minus kx. What is the general equation of the progressive wave? Y equals to A sine omega t minus kx. What is the velocity of the wave here? There are different formulas for the velocity of the wave. For the general wave, velocity is v is equal to omega by k, or you can take v is equal to f lambda, or you can take it is equal to root of t divided by mu, where t represents the tension, mu represents the mass per unit length. Mu represents mass per unit length. And also velocity is defined as root of gamma RT by m. Gamma RT by m. So these are the formulas for the velocity of the different waves. This is for the progressive wave. After analyzing this progressive wave, the problem is going to be asked about the concept of the stationary waves. The problem is going to be asked based on the stationary waves. What is the general equation of the stationary waves? Y is equal to A sine omega t into cos kx. So the general equation of the stationary wave is A cos omega t into cos kx. Usually here you are going to get the two different concepts. One is going to be the closed pipe. The second one is going to be for open pipe. For closed pipe, one end will be closed. If both the ends are open, then it is said to be an open pipe. What is the frequency of the closed pipe? It is V divided by 4L. What is the frequency of the open pipe? It is V by 2L. One is V by 2L. The second one is V by 4L. So for closed pipe, you have to make use of always V by 4L. For open pipe, it is V by 2L. This is the first frequency, first case frequency. From this, if you want to go for the second frequency, then it will be 3 times of V by 4L. If you want the third frequency, it will be 5 times of V by 4L. What is the frequency of the second case here? 2 times of V by 2L. Third frequency will be 3 times of V by 2L. So clearly you can tell, in the case of the closed pipe, the frequency ratio will be, it goes always 1:3:5. Look at the number. It is 1 times of V by 4L. It is 3 times. It is 5 times. 1:3:5. But in the case of an open pipe, it will be in the ratio 1:2:3. 1:2:3. So for closed pipe, it will be in the ratio 1:3:5. For open pipe, it will be in the ratio 1:2:3. So whenever they are going to ask any particular fundamental frequency, you have to be in a position to write the formulas here. Suppose if they are talking third fundamental frequency of the closed pipe, third fundamental frequency of the closed pipe is equal to the second fundamental frequency of the open pipe, then what you will write? Example I'm saying. If I say the third fundamental frequency of the closed pipe is equal to the second fundamental frequency of the open pipe, what you will write the equation? What is the formula for the F3C? What is the formula for the third frequency of the closed pipe? For closed pipe, it is V by 4L. If you want for F3 means 1:3:5 ratio. So for F3, you have to write 5 times of V by 4L. 5 times of V by 4L must be equal to second frequency of the open pipe. For open pipe, it is V by 2L. It is 2 times. So 5 times of V by 4L is equal to 2 times of V by 2L. So these are the two frequencies when they are saying that they are equal. So 5 times of V by 4L must be equal to 2 times of V by 2L. So the problems maybe come from the closed pipe and the open pipe. You have to be very careful, students. The next concept. This is also very important. That is about the concept of baits. Concept of the baits. Yeah. In this baits, actually we are going to determine the frequency. We are going to determine the frequency of a tuning fork. We are using the baits to determine the frequency of a tuning fork. Now, the first thing, if I consider the excuse me, if I consider the two tuning forks, let us say this tuning fork is having a frequency F1. Then there is another tuning fork of tuning fork F2. When these two tuning forks are going to strike each other, when the two tuning forks are going to strike each other, then the number of beats heard per second is always equal to F1 difference F2. Beat frequency is always equal to F1 difference F2. So how to determine the frequency of the beats? Beat frequency of the tuning fork is equal to F1 difference F2. F1 minus F2 or F2 minus F1. For example, I'm going to give one tuning fork like this. The frequency of this tuning fork is 100 Hertz. There is one more tuning fork. One more tuning fork, the frequency is 95 Hertz. Second tuning fork is having a frequency 95 Hertz. If I strike this too, can you tell me what will be the beat frequency? What will be the beat frequency? Difference, no. 100 minus 95. 100 minus 95 is how much? 5 Hertz. Now, this is the tuning fork of frequency F1. This is the second tuning fork of frequency F2. You have to calculate this. F1 I am giving 100 Hertz. Now, when you strike these two tuning forks, what is the beat frequency you are getting? Let us say the beat frequency is 10 Hertz. Can you tell me the value for F2? Anyone can tell me what is the value of F2? Dhanlakshmi, can you tell me what is the value of F2?
Sir, 90 Hertz.
F2 is 90 Hertz. Okay. How you got this 90 Hertz, Appa?
Sir, if we subtract 90 from 100, we'll get 10 Hertz.
Yeah. Now, instead of taking 90, if I take 110 Hertz, if I take the difference between 110 and 100, I will get 10 only, no?
Yes, sir.
So, for F2, there will be a possibility of two values.
Yes, sir.
Either 90 or 110. So be very careful. When they are given F1, F2, if they ask beat frequency, it is very simple. But if they have given F1 and beat frequency, to calculate F2, it is very tough. Because you'll get the two answers. Either 90 Hertz or 110 Hertz. Then how you have to solve this? For this, there is a procedure. Now, one of the tuning forks should be waxed. One of the tuning fork must be waxed. If you waxed one of the tuning fork, then that particular frequency will decrease. Which tuning fork you are doing wax, that frequency will decrease. After wax, you determine new beat frequency. You determine new beat frequency. This should be either more or it should be less than the original beat frequency. Depending upon this FB dash, find unknown frequency. Find unknown frequency. So this is the procedure you have to remember. Now, I will give one tuning fork. I will give one tuning fork F1 100 Hz. I will give the another tuning fork. This tuning fork is F2 question mark. I will strike these two tuning forks. Beat frequency is found to be 10 Hz. Now you can't tell what is the value of F2 because F2 may be 90 Hz or it may be 110 Hz. It may be 90 Hz or it may be 110 Hz. So what I'm going to give, I will say that F1 is waxed. Then new beat frequency is found to be 12 Hz. These are the two conditions I'm giving. Since you can't determine F2 directly, I'm giving the two conditions apart. What's the first condition? F1 tuning fork is waxed. After waxing F1, new beat frequency is found to be 12 Hz. New beat frequency is found to be 12 Hz. Now, according to your concept, beat frequency should be the difference of the two tuning forks. Either FB equals to F1 minus F2 or FB equals to F2 minus F1. So FB is equal to F1 minus F2 or FB is equal to F2 minus F1. Clearly in this problem they are telling that F1 is waxed. Which tuning fork will be waxed? What will happen to that particular frequency? ಯಾವ frequency ನೀವು wax ಮಾಡ್ತೀರಾ ಆ frequency ಏನಾಗುತ್ತೋ decrease ಆಗುತ್ತೆ. So F1 will be decreased here. F1 will be decreased here. F1 ಕಡಿಮೆ ಆಗಿದೆ. After waxing, beat frequency ಎಷ್ಟಾಗಿದೆ ಇಲ್ಲಿ? 12 Hz. ಮುಂಚೆ ಎಷ್ಟಿದೆ? 10 Hz. So 10 Hz ಇರೋದು 12 Hz ಆಗಿದೆ ಅಂದ್ರೆ beat frequency has increased. Beat frequency has increased. Now you tell me which equation is correct. If the first number is decreased here, the difference has to decrease, right? But it is increased here. So this equation is wrong. This equation is correct. So if the first term decreases means the difference should decrease. But they are telling that the new beat frequency is increasing. So FB dash is equal to F2 minus F1. So FB is how much? 10. F2 will be unknown, you have to find. F1 is 100. If I shift 100 to that side, it becomes 100 plus 10. That is 110 hertz. So what is the frequency of the second tuning fork? F2 value will be 110 hertz. So F2 value will be 110 hertz. So 90 is not possible. 110 is the correct answer. So this is how you are finding the frequency of the tuning fork by using the concept of bits. Then one more concept is there apart from the waves chapter only. Usually this is also going to be asked. Doppler effect. I think you have studied the different cases in the Doppler effect, but for the competitive level, you can't remember all the different cases, every cases you can't put the separate formulas. So please remember here, I'm going to give the general formula for the apparent frequency. That is V plus or minus V naught divided by V plus or minus Vs into F. So F dash is equal to V plus or minus V naught divided by V plus or minus Vs into F. This F is the actual true frequency. V naught is the velocity of the observer. Vs is the velocity of the source. And V is the velocity of the sound. That V value is constant, that is 332 meter per second. V is always constant, that is 332 meter per second. What is V naught? V naught is the velocity of observer. Vs is the velocity of source. F is actual frequency. Sir, why you are writing plus or minus? You have to use either plus or minus only. But general formula I am giving, that is plus or minus V naught divided by plus or minus Vs into F. I'll take one simple example here. Now, there is a railway platform here. On the railway platform, there is an observer here. Now here there is a train. Now the train is moving. So this train is putting a Rn of particular frequency F. When you put the Rn of particular frequency, the wave is going to reach the observer with frequency F dash. What is the frequency heard by the observer? The frequency heard by the observer is F dash. F dash. Now, if the train approaches up to observer, its apparent frequency goes on increasing, right? If the apparent frequency goes on increasing, please write plus in the numerator and minus in the denominator. If apparent frequency is increasing means numerator should be positive, denominator should be negative. Once if the train passes away from the observer, if the train passes away from the observer, what will be the apparent frequency now? It will be less than the actual or it will be more than the actual. If the train is moving away means the frequency has to decrease, right? So, if the apparent frequency is decreasing means numerator should be minus, denominator should be positive. Numerator should be minus, denominator should be plus. So, V minus V naught by V plus Vs into F. So please be very careful, students. If the apparent frequency is increasing, you have to use plus in the numerator and minus in the denominator. If the apparent frequency decreasing means numerator should be minus, denominator must be positive. Clear? You have to be very careful. If the observer is at rest, then you have to take the velocity of the observer as what? 0. What is the velocity of the observer? 0. And please remember, if the source is moving in the circular path, if the source is moving in the circular path, if there is no relative motion here, no relative motion. If no relative motion is there, Doppler effect is not going to change. We can't apply the Doppler effect for this case. Doppler effect is going to be valid only if there is a relative motion. Only when there is a relative motion. Got it? Yeah. Then one of the another important formula they may ask upon, that is related to the speed of sound. No doubt, the speed of sound at STP. STP means standard temperature pressure. At standard temperature pressure, the speed of sound is 332 meter per second at STP. But what will happen to the velocity of sound if the temperature increases? If the temperature increases, the velocity of sound also increases. Please remember, if the temperature of the surrounding medium increases, then the velocity of the sound increases. So clearly you can tell velocity of the sound is directly proportional to square root of temperature. Velocity of sound is directly proportional to square root of temperature. As temperature increases, velocity of sound increases. But also please remember, velocity of sound is independent of pressure. Velocity of sound is independent of pressure. So even though if you increase the pressure or if you decrease the pressure, the velocity of sound will not change. The velocity of sound will not change even if you increase or decrease the pressure. Got it? So this is the synopsis part of two important chapters, that is oscillations and waves. So totally we may get around 3 to 4 questions from this two chapters. Is it okay then, Lakshmi? The synopsis have you got?
Yes, sir.
What about Tanushri, Roslyn? Okay, Tanushri, got it. Yeah. Fine, Appa. So in the next class, we'll discuss the 6th paper. After completing that 6th paper, I will try to do it in one day, that 6th paper. Then 2 days we'll keep for the synopsis. Then we'll go with work power energy, rotational motion, gravitation, and loss of motion. These are the other 4 important chapters where you will get around 3-4 questions in each chapter. Okay, Appa, I will stop at this stage. We'll continue in the next session. Thank you, students. Have a nice evening. Bye-bye.